Hello and welcome to the OCR Further Maths videos for Pure Core. This is Matrices 5, Matrices and Simultaneous Equations, and this is video 5.1, solving two simultaneous equations. So we can solve simultaneous equations using matrices. We write our system of simultaneous equations in matrix form, like this. But in order to find out what x and y are, you can't divide by a matrix. However, if you pre-multiply by its inverse, it has the same effect. So if we multiply here by the inverse of m, you can see we have inverse mm times xy is equal to the inverse of m times x1, y1. Now, we should know from our previous work on matrices that the inverse of a matrix times a matrix is just the identity matrix. So we can see we have the identity matrix times xy is equal to the inverse matrix times x1, y1, and therefore we can solve our simultaneous equations because x, y are given by the inverse matrix times our solutions to the simultaneous equations. So here we have some simultaneous equations that we would like to solve. 3x minus 5y equals 4, 2x plus 4y equals 7. So these equations can be rewritten as a single matrix equation. 3 minus 5, 2, 4 times xy is equal to 4, 7. And what we want to do to solve it is to pre-multiply by the inverse of the 2 by 2 matrix. So find the inverse of the matrix, and to do that we're going to need to know the determinant of the matrix. So that is 12 minus 10, which is 22. So the inverse matrix 1 over 22 times by 4, 5 minus 2, 3. So we know what the inverse matrix is. Which of the following is true? We should find out that this is the correct matrix equation to find our solution. And if you follow through with the working, you should end up with x equals 51 over 22, y equals 13 over 22. So, linear equations in two variables can be represented in a plane by two straight lines. When you solve simultaneous equations in 2D, there are three possibilities. What are they? Hint for that is draw a sketch. Let's think about those possible solutions. So, we could have two lines that meet at one unique point. For example, that. And you could have two lines that are parallel and never meet. For example, that. Or you could have two parallel lines that are coincident, i.e. they are the same line. Now we can use the value of the determinant to give us a clue about which of these cases we have. If the determinant is not equal to 0, then we have a unique solution. If the determinant equals 0, we can either have infinitely many solutions because they are the same line, or we can have no solutions because they are parallel lines. So let's have a look at this example. We want to find two values of k for which these equations do not have a unique solution. So we know that in order for them to not have a unique solution, the determinant of the matrix needs to be 0. So let's write this as a matrix equation. Times xy equals 5 minus 10. So here's our matrix A, and we want the determinant of that to equal 0. So that means that 4 minus k squared equals 0. K squared equals 4, so k can be plus or minus 2. If we think about the situation where k equals 2, we would have x plus 2y equals 5, 2x plus 4y equals minus 10. These have no solutions, so these must be parallel lines. If we have k equals minus 2, we have x minus 2y equals 5, and minus 2x plus 4y equals minus 10. You can see here that the second equation is just a multiple of the first one. So they must have multiple solutions, so they are coincident lines. Okay, the next video in this series will be 5.2, 3 simultaneous equations with a unique solution.